in this example, we're going to use synthetic division instead of long division to divide 2x cubed minus x squared minus 13x plus 1 by x minus 3. Long division will definitely work here. In fact, long division always works, but it's nice to use synthetic division when possible. So the only times that you can use synthetic division are when you are dividing by something that looks like this. So notice a couple things. It's a binomial that we're dividing by, where the greatest exponent is 1. All right, so it must be a binomial. This c represents a constant, so any number. This could be x minus 1, x minus 2, x plus 3. It doesn't have to be minus, because minus can be rewritten as x plus a negative number. All right, so as long as it's a binomial like this, where the greatest exponent of x is 1 and not something like x squared minus 3 or x cubed, then we are allowed to use synthetic division. So it is a very specific case where you're allowed to use synthetic division. So when you can, definitely use it, because it's a faster method. But sometimes you can't avoid long division because synthetic will not work properly for it. So when we set up synthetic division, all we're doing is we're using coefficients. All right. So you always want to check and make sure that no terms are missing. So that's still true here. So here's a cube, that's the greatest exponent. I do have a squared, I do have x to the first, and then I have no x, so x to the 0. Same thing in my divisor. I have x to the first, and then x to the 0, really, no x. So no terms are missing. If there was a term missing, it would only be in this if you're using synthetic division, because if x is to the first power, there's no term that's going to be missing if you have the constant. So let's say, for example, the x squared wasn't here. Then when you write out the terms, you would have 2 as your coefficient for x cubed. You would have 0 as your coefficient for x squared, if that were the case. But let's go ahead and take a look at this one where there are no terms that are missing. So I'm only going to write the coefficients. So the coefficient of x cubed is 2. The coefficient of x squared is negative 1. The next coefficient is negative 13. And then the next coefficient is a positive 1. All right, and then we're going to make this little box right here. All right, and we're going to take the opposite of this constant, the opposite. So this is a negative 3. So in my box, I'm going to make that a positive 3. All right, and then I'm going to go ahead and just draw a line here, and we're going to see all of the operations that we're going to be using. So the very first step in synthetic division, and this only happens in the very beginning, so it happens once, is we bring down that first term. All right, so I'm going to bring down that 2. All right, and then I'm going to start multiplying. So I'm going to go ahead and write down these steps just like I did for long division in the previous example. So 2 times 3 is 6. I'm going to go ahead and put that under the second one. And then I'm going to add. All right, so negative 1 plus 6 is a positive 5. All right, and then I'm going to go ahead and multiply again. So 5 times 3 is 15. I'm going to go ahead and add. So negative 13 plus 15 is a positive 2. I'm going to go ahead and multiply again. 2 times 3 is 6. And I'm going to add 1 plus 6 is 7. And we're going to do something interesting here. We're also going to box in that last number. So there's boxes at the opposite diagonals right here. All right. So now we are done dividing, but we have to figure out what all these numbers actually mean. So when we divide by x minus 3, we are going to have these coefficients and remainder in our final answer. So now we have to go ahead and put back the x's that we took away. All right. Now, anytime you divide 2x cubed or any number by an x, we're going to go down in degree, down in exponent. So because my greatest exponent here is 3, in my final answer, I'm going to start with x squared, the next one down. All right, this 5 is positive. I'm just going to keep going down in order. Instead of x squared, now I have x to the first. This 2 is positive. I have x to the first, no x. Now this is my remainder. So I'm just going to write this out nicely. My final answer is 2x squared plus 5x plus 2. And remember that anytime we have a remainder, we're going to put it over the original divisor, what we were dividing by. So this is going to be plus 7 is the remainder, so that goes in the numerator, divided by x minus 3. And that is my final answer. So far, in both the problems that we did, we got a remainder. That doesn't always happen. If you get 0 here, then you have no remainder, and you would just have an answer with no fraction in it. Sometimes it'll work out perfectly. So even though the last two examples have had remainders, that doesn't always happen.